Logarithmic. Properties of logarithmic. That's what we're gonna talk about first. First question it says, I need to show log a1 is equal to 0. I need to show this. Log a1 is equal to 0. Okay. Jose?
Yeah.
Whatever we did yesterday, can you use those things and tell me how can I prove this? Any idea? I taught you how to convert into exponential. When I convert this into exponential, what does it become?
You'll get base a to the power of 0 equals 1.
Yes, you get this thing when you convert into exponential. Perfect. And I told you yesterday in exponential, anything raised to power 0 is
1.
1, which we already know. Anything raised to power 0 is 1. Hence proved. Hence proved. So you get this thing here. Or you can, other way of proving it is, you put log a1 is equal to y. You solve for y. You get a to the power of y is equal to 1. You get this thing. That's another way of doing it. And 1 you can write as a to the power of 0. So you get y is equal to 0. That's another way of doing it. I wrote it equal to y. A to the power of y is equal to 1. It comes out to be a to the y is equal to 1. I mean, you don't need the prove this, but the first property I'm going to explain. First property is if you have log, no matter what your base is, no matter what my base is, log a1 is always equal to 0. That's the property. No matter what my base is here, it's 10, 50, 100, I don't care. But if I'm finding log a1, if I'm finding log of 1 here, it is always equal to 0. Similarly, if ln is basically log base e, ln1 will also be equal to 0. So this is the first property. Property 1. On the top, it was just the explanation how we got it. Second property is, so if you want to take example for this, if I give you example for this thing is, if I say log 101, I again say, no matter what my base is, here my base is 100, I don't care what my base is, log 1 I know is always 0. Directly I should know it is 0. Second is, if you have log AA, it is always equal to 1. It is always equal to 1. So if my base and my number here, they are the same thing. Actually, it is equal to 1. Similarly, ln E is also 1. The reason is because, note, if you want to make yourself, the reason it is because ln is actually log base e. What is ln? Log with base e. So it becomes log base e. Since they are the same thing, the base and this thing is the same, that's why it's equal to 1. Example, I say what is log 2. My base and the number, they are exactly the same here. It comes out equal to 1. Also, one thing you should note too also, when I just say log, generally I mean the log has base as 10. Whenever in the question it's just written log, they mean the base is 10. And whenever they say ln, you should know the base is e. Any questions with this? Two properties. So you will be using these. I'm going to give you 4 properties and then we'll go on questions. So your third property is, it says if my a is raised to power log with same base a m. Note, my a is raised to power log. In the exponent I have log with the same base a and m. It actually comes out to be just m. You can say this cancel or how you want to remember, it's up to you. Similarly, they are saying if you have log a to the power of r, a to the power of r, it will come out to be equal to r. So these are the 4 properties of logarithmic which we are studying right now. There are more, but so far you should know. If you have 1 here.
That's a pi symbol, right?
Which one?
On number
no,
4,
no, that's r. I don't know how you guys write r. I mean, it's r. This is r. This is not pi, this is r.
Okay, thank you.
Yeah. So now let's do properties on this. So example, I'm going to do examples on this. It says you have to find the value of 2, and 2 is raised to power 2 log pi. 2 is raised to power 2 log pi. Axel, Jelena, okay, Carly.
Yes.
Yeah. What do you think is the value of this thing? 2 log 2 pi.
Would it be pi?
Pi. The reason is I'm using my third property here. See, my base is this exponent, this base and this base, log base. They're exactly the same. So technically they cancel and you're left with just pi. Correct. Okay, let's see. Log 0.2 to the power of negative square root of 2. Can I have Hawking? Nick? Hawking, Nick are not there. Alejandro?
Wouldn't that be 1? Because since you're multiplying 0 and 2, it'll turn itself into 0.
Which one? Which property are you using?
In which case it might be 1, right?
Why it would be 1? See here.
Because you're multiplying the 0 and the 2, right?
No, it's not multiple, it's decimal. 0.2.
Oh, 0.2. It looks like multiplication.
No,
Sorry.
it's decimal. It's decimal. So Alejandro, yeah. What do you think is the value of this thing? It's not clear. I cannot hear you. How does it look like? It looks like here, right? It looks like here, see. Log, here also base same, here also 0.2 and raised to power negative square root 2. It will be equal to what? It will be equal to negative square root 2. Basically the same base and the base of this exponent power, they just cancel and you're left with negative square root 2. Let's do one more example. You have ln e to the power of kt. Ln e to the power of kt. Okay, let's see. Eduardo?
Yeah.
What is ln e to the power of kt?
Okay, KB?
K and T. What do you think the answer is this one? What is ln?
Log base e.
Yeah, it's log with base e. So it's basically you get this thing, which is equal to what? Come on, Eduardo.
Because I was originally answering like into 1 for the log for the 0.2. So I wasn't really following your way.
Okay, let's see this one. Forget about this one. I'm talking about the new one, new question here. What is the value?
Sorry, just that I thought that was supposed to be include like part of the problem, or probably the problems that we did proof for.
Which one? I don't get it. Where you are confused? Which problem are you confused? 1, 2, or 3? This side number is 1. This side number is 2. Example 3. Which are you confused about? I cannot hear you, Eduardo. You're on mute.
Repeat that again.
Which question are you confused about? 1, 2, or 3?
I mean, I wasn't doing 3. Sorry, just that I assumed that 3 was going to be part of the problem.
No. So, do you know the answer for third one?
No.
So, do you compare? You have log base e to the power of kt. I gave you 4 properties here. 1, 2, 3, 4. Does it look like any of these 4?
Yeah, isn't it the ln e equals 1? So don't we turn the ln e into a 1 over kt? 1 power kt?
So, see here. In this one, do you have a power here? Do you see a power here? Is a raised to power anything here, Eduardo?
No.
No. So, I'm not using this property. Look at this property here. Do I have a power here?
No.
I don't have a power here. Is a is raised to power some r here? I have a power here. So in this case, what happens is it is just kt. It comes out equal to just the power. Are you getting my point, Eduardo, or no?
Yeah.
Yeah. Okay. Anyone who's not understanding this, these properties are important here. It's very easy, and this is a place you score a lot. These properties. I'm gonna go to more properties here. So we did 4 properties. The fifth property says if you have log some base and you're multiplying inside 2 numbers, you're multiplying m times n. You're multiplying 2 numbers inside m times n. You can actually separate it. It becomes log with the same base a. If my base was here, a, here also my base will remain same. I can separate m plus, it becomes plus log with same base n. So multiplication changes into addition with the same base. Multiplication changes into addition with the same base. Similarly, if you have log a m over n, it will change into log a m, but in this case, from the numerator you're going to subtract the denominator. Note my base still remains the same. You're not going to touch your base. If it's a, it will still remain a. Another thing, so this is the 6th property. 7th property which we are learning is if you have log some base a m to the power of r. This is r, guys, this is r. If you have log some base and m is raised to power r, you know what does log? This is very important property here. Very, very important property here. If you have log some base and m is raised to power r, the special property of log is it picks up the power and throws in front. It picks up this power and will throw in front, and everything else will remain as it is. A very interesting point of logarithmic is it picks up the power and throws in front. So this r will be thrown in front and you will be left with this thing. This thing is r, not pi, guys. Keep this in mind. And other thing you can write is, if you have something like E R ln A, I would suggest don't remember this. Don't remember this. You can prove this. You don't have to remember so many properties. These are the main properties which you're gonna remember. These are the main properties you're gonna remember. Don't remember this property because you can prove this yourself. Okay. It says you're given the question you'll get on this is, it will be given as write log base a x square root of x square plus 1 x greater than 0 as the sum of logarithmic. Express all powers as fractions. Now you have to expand, or they will say just expand this thing. So you are given log base a x square root of x square plus 1. Note you have two terms, x and x square plus 1, and they are multiplying each other. How can I do it is, since they are multiplying each other, I can change into addition. I know multiplication changes into addition. I know that with the same base. Since my base here was a, I will have my base here also as a. And it becomes log a the first term and log a the second term. I cannot do anything about this. This is already expanded. You cannot do anything about it. But here, log a, you have log a square root of x square plus 1. Note square root is basically 1/2. They want you to convert into fraction. Can I use any more properties on that? First term will remain as it is plus. Can I do anything about it? I told you there's a very interesting property about exponential is, whatever is the power, it picks that power and throws in front. It will become 1 to log a x square plus 1. Can I expand it further? I cannot expand this further. 1 to, okay, x square plus 1. I have plus here. And I don't know any property with the plus sign here. I know about multiplication and division. If they are multiplying or dividing, then I know. But since here they are adding, I don't know anything. So this is your final answer. I want you guys to try this. So you have example you have is, I would say log a u square v cube. Expand this as much as you can. Log base a u square v cube. Karen?
Yes.
Can you help me with this?
Okay. Log
Yeah.
a
Yeah. What are these two terms doing with each other here, Karen?
multiply
Multiplying. What happens when they are multiplying? Which property do you use?
the number 5.
5. So it changes into addition, right?
Mm-hmm.
So I'll distribute the log. What does it become?
Log a u square
Yeah. And then plus sign, multiplication
Plus.
change. Yeah.
log a
Yeah.
b cube.
Yes. Perfect. Can I expand it further? Log a u square. What happens when a logarithmic has an exponent here, a power? you know what happens, Karen, here? Whenever you have a power, the log will pick it up and throw in front. And you will
Okay.
left with rest of the stuff here. What about the
Okay.
second one? Can you tell me what will be here?
Okay. 3 log A B.
Perfect. Perfect. And you cannot expand any further. So that's it.
Okay.
Yeah, good. Any questions, anyone? Let's do one more question. ln ex. I want you to expand this as much as you can. ln ex was Shira.
Yes.
Okay, what about this thing?
I might need help.
Okay, you have to see when you're expanding, either you're using this property or this property. Which one do you think I'm gonna use?
Oh.
Are they multiplying inside or dividing?
They're multiplying.
When
So it's gonna
multiplication-
be the first one.
Yeah, so what does it become?
ln E plus ln X.
Perfect. ln e plus ln x. Do you know what is ln e, Shara?
1.
1, because it is log base e and e, which is 1, and you get ln x. Perfect, that's it. You cannot solve further, so you leave your answer there. You solve as much as you can, and that's how you get your answer.
Okay.
Perfect.
I've got a question.
So only ln E can be 1, right? So
ln
you can't-
e can be 1, or if I say log 2, you get 2. Your number is the same and your base and the number exactly are the same. Why is ln e 1 is because...
Yeah, I'm just explaining about it's only E, right?
Yes,
It can't
only
be
E.
any other letter.
No, it cannot be any other letter because ln is log e. ln is log with base e.
Okay, thanks.
Yeah. Any other question, anyone?
Yes. If I switched it to log base e, are we allowed to keep it as log base e? So my answer was like 1 plus log base e x.
Yeah, that's correct. That's not wrong. But the thing is, in MyLab, maybe if you enter log base e, it will take it as a wrong answer.
Okay, so I gotta switch it back.
Yeah, switch it back to ln. I mean, you can solve using log base e, but at the end, switch it log base e to ln.
Okay.
Yeah. Any other question, anyone? Okay. Let's see, one more problem I'm gonna do is, okay, let's see. Okay, you are given one more example. You have log 5 25x. I say you have to solve this. Log 5 25x. Samantha, expand this.
So it would be log 5, and then 25, and then plus log 5.
X.
Yeah.
Okay. What about, can I solve this further, Samantha? Can I write 25 as 5 to the power of something?
Excuse me?
Can I write 25 as 5 to the power of something?
Yeah.
What is it?
5 to the power of 2.
5 to the power of 2. You get log, and log 5x remains as it is, as I cannot do much about it. What is the value of this thing?
So it would be 2 log 5.
It will be equal to what?
2
Mm-hmm.
log 5. And then 5.
X. Are you getting it?
Yeah.
Yeah.
Okay.
This is a property we did. This is one of the properties we did initially. My fourth property. This was the fourth property we use.
Okay. When you only write 2 when they're both the same
Yeah,
number.
exactly. They're both the same, so they cancel. Or if you don't remember this step, how you can do it is, after this, what you can do is what does log does? It picks up the exponent and throws in front, right? So you get log 5 is equal to log 5x. And what is log 5? Same base this. What is the value of this thing?
Okay.
What is it? What happens when your base is the same? See these properties and tell me what happens when your base is the same and the number there is the same.
Oh, it's 1.
It's 1. So this value becomes 1 and you get log 5x, which is 2 plus log 5x. You can remember that way also.
Okay.
Logarithmic throws exponent in front and then this value becomes 1.
Because for property 7,
Yeah,
the exponent goes to.
in front.
Okay.
Yeah, it picks it up and throws in front. Yes. Any other question, anyone? No, everyone got it? Okay. So I'm gonna go to now division. Okay, suppose they say now you need to expand ln x square over x minus 1 to the power of 3. They want you to expand this now. Okay, and note my x cannot be equal to 1 because if I put here 1, what will happen? My denominator will become 0. 1 minus 1, 0, and I cannot have my denominator as 0. So this is what given in the question. Or they are saying x should be greater than 1. That's what they are saying in the question. This is the question given to you. They say you have to expand as much as you can. Note, division changes, multiplication changes into addition, division changes into subtraction. Whatever is in the top, ln of first, you're going to write that thing, ln of the numerator, minus. Now you're going to put a minus sign, not the positive. Since it's division, it becomes ln of the denominator. Okay. In this case, can I expand it further? Yes. I see your
Yes,
power.
you can expand the power 3, right?
Yes. So here what you do is, since you have a 2 here, x is raised to power 2 here, and you have a power, it's going to pick up and throw in front. You get 2n ln x. Minus here also you have 3 as a power, it's going to pick up and throw in front. ln x minus 1. Can I expand it further? This thing, no, what about this thing? X minus 1. I cannot. I have just taught you about multiplication and division. I have never taught you about addition and subtraction inside. I haven't taught you, so you cannot expand further. This is your final answer. Any questions? Let's do more examples on this. So if I say you have to find, let's see here, they have log 3x over 9. They want you to solve this, expand this as much as you can. Angel? Not here. Miguel? Not here. Hugo? Hugo is not here.
I mean, I can go for it.
Oh yeah, Edward. Okay, perfect. Yes.
Since that's also going to be a division, we also have to subtract it too, right?
Yes.
It's going to be log 3x minus log 3, 9.
Okay. Can you expand it further, Eduardo?
I don't believe so.
You don't believe so? Okay, this I cannot do it because it's log 3x.
Yeah.
But you have to think, can you write 9 as the same base to the power of something?
Yeah, you can make it to log 3 to 3 to the power of 2.
Perfect.
And then you can bring that 2 over
Yes.
into 2 log 3 power 3, which makes into 1, right?
Yes. So what do you get? Log 3x?
Which is log 3x minus 1, right?
Minus 2, minus 2.
2 times 1,
Yeah,
which
which is-
makes into just 2.
Yes. Perfect. Perfect, Eduardo. Yes.
I mean, now you finally be able to get it now.
Okay, perfect. Yeah, these properties, You don't have to remember those properties. I mean, that much. If you know this property that you can throw in front and this becomes 1, you're good. Yeah. Anyone, any question with how we got this thing here? Okay, let's do one more property on this thing. Okay. Let's see. So D here, I'm gonna give you one more example is you have log base 5 cube root of x square plus 1 over x square minus 1. You have this thing here. You need to solve. Christopher,
Yes.
what do you get for this thing?
So since there's multiplying in the numerator, I believe you have to separate those.
Where are they multiplying in the numerator?
3. Is that the cube
root. It's a cube root. It's a cube root, yeah.
Okay, never mind. Sorry.
Yeah.
So since it's division, you have to subtract. So it's log base 5 of cube root x squared plus 1.
Okay.
And then minus log base 5 of x squared minus 1.
Okay, perfect. Okay. And then what's the next step? Can you expand further?
And then the cubed root turns into 1/3 exponent.
Okay.
So it's log base 5 of x squared plus 1 to the 1/3 power.
Okay. What's the next step?
The 1/3 power goes in front of log base 5.
Okay, you get log 5 x squared plus 1 minus log 5 x squared minus 1. What's the next step?
I believe that's it.
Yeah, that's it. You cannot do it further. You cannot, because it's addition or subtraction inside. You don't know anything about that. So that's it. That's your answer.
Yes, sir. Why does the 1/3 jump to the back of the x2 plus 1? Does it have to stay in front?
The thing is, that's a property of exponential. Whenever you have a power, it picks it up and throws in front. So here it will become 1/3 log 5 x squared plus 1. It always picks up the whole power and throws in front. Yeah. Any other questions, anyone? Okay. Suppose now I'm going to do one more example here. You have log a square root of x square plus 1 over x cube, and then you have x plus 1 to the power of 4. You have to expand this as much as you can. Joshua?
Yeah.
Okay, help me with this one.
So it'll be log a square root x squared plus 1 minus
Okay.
log a x3 x1 or x plus 1 to the power of 4.
Okay, perfect. Try to expand it. Let's see. What does this become? X squared plus 1, square root of x squared plus 1.
2. It'll be to the power of 2.
To the power of 2, or it's square root?
1/2.
1/2. Perfect. What about here? What can I do here, Joshua?
To the power of 4. So you could.
So first of all, what are they doing with x cube and x plus 1 to the power of 4, right? They are two terms. What are they doing with each other?
Well, actually, it's multiplying and 4 is dividing.
So what happens when you multiply?
Distribute.
See, division you change into subtraction, right? They were dividing each other, you change into subtraction.
Oh,
But now here they're multiplying here. What can you do when they're multiplying?
is it multiplying? I think it was adding.
Yes, adding. But make sure when you are opening after minus sign, make sure you put a bracket. Very important step here. Important step here. So if you're trying to expand after a negative sign, make sure you put in a bracket. What does it become, Joshua?
Log a. What is it? X3 plus log a x plus 1 4 to the power of 4.
Yes, perfect. What does this become, Joshua? This one?
Oh, wait, couldn't you move the 1/2 to the front?
Yes, we'll put 1/2 in the front and you get log a x square plus 1 minus, what about this term here?
That one would be x3 log a.
x3?
X to the power of 3.
No, this 3 will come in front, right? The power?
Oh, yeah, sorry. 3 log ax.
3 log ax. Perfect. What about this one?
That would be 4 log a, or x plus 1.
X plus 1. Perfect. Let's open the bracket. I don't want to deal with brackets anymore. We have to open the brackets. Distribute the minus sign. What is minus multiplied by this whole thing?
Negative.
Okay, it becomes negative 3 log ax. Similarly, this will also become negative 4 log a x plus 1. What else I can do about here, Joshua? Can I expand this?
You what?
Can I expand this x square plus 1?
I believe so.
You cannot. You can only expand if they are multiplying or dividing.
Oh, okay.
You cannot expand if they are adding or subtracting. So I cannot expand this, I cannot expand this. This is the maximum you can expand. So this is your answer.
Oh, okay.
Yeah, perfect, Joshua. This is the important step here, guys. When you are opening after a minus sign, make sure you put in a bracket. Don't open without using a bracket. Any questions, anyone? Let's do more problems on this. Let's see here. You have, okay, this is one of the toughest ones you're gonna get. So if you know how to do this, this is good. So you have ln 5x square cube root of 1 minus x over 4 x plus 1 whole square. You're given this thing here. You're given this thing here. Okay. Is was here? Was Angel Miguel? No? Gerald?
Hello.
Hi, Gerald. Yeah. So let's solve this one. What does it become?
All right. So the first step that we're going to do is that we're going to separate them. So we're going to have ln 5x squared cube root 1 minus x minus 4 times x plus 1 squared.
ln.
Yes, ln.
Yeah.
I forgot.
Yeah.
ln.
Okay. You got this thing.
And then to expand the first one even further, because they're multiplying, we're going to have ln 5x squared plus...
No, Gerald. 5 is also multiplying, x squared is also multiplied, and that thing is also multiplying.
Oh, so we separate to ln 5 plus ln x squared plus ln cube root 1 minus x.
Cube root 1 minus x. Okay.
And then the ln x squared can turn into
First here.
ln.
After minus sign.
For that one, we're gonna do ln 4 plus ln x plus 1.
Yes. ln x plus 1 square, right?
Yes.
Is there something wrong I did here, Gerald?
You didn't include your brackets, so you want brackets in front of ln 5 and
Now, in front of ln 4 plus ln x plus 1 whole square. Whenever you are opening after the minus sign, since I'm opening...
Oh, after the minus sign,
after
okay.
minus sign. You don't have to put in before, but after minus sign, if you are doing it, then make sure you put in a bracket. Okay.
Okay.
What does it become?
So ln 5 stays the same. And then ln x squared, you put the 2 in front of the ln. So you're going to have 2 times ln x.
Okay.
And then for ln cube root of 1 minus x, that will turn into ln 1 minus x to the power of 1/3, and then that will then change into 1/3 times ln 1 minus x.
Okay. Then,
The ln4 stays the same,
and I open the bracket so it becomes minus ln4.
so yeah, minus.
And then,
And then you're going to have minus ln, or minus 2 times ln x plus 1.
perfect. And can you expand further?
No.
Okay, perfect. Any problem with this here, this question here specifically? Anyone? No? So let's see here what else you have. So now you have to, what first we were doing is we were expanding. You were given one logarithmic, you had to expand. Now we are going backward. It will be given expanded form. You have to go backward and make it into one logarithmic. So example here. Okay, example you're given log a7 plus 4 log a3. They want you to write as a single logarithmic. Log a7 plus log a3. How do you do it is, first of all, log a7 you cannot do much, keep as it is. I have this 4 here in front. Note what did log do is it picked up the exponent and threw in front. Now I'm going to go backward. I'm going to put it back now here. So it becomes log a 3 to the power of 4. Now I put it back. And since my bases are the same, addition,